Now I'd like to request all the delegates to prepare your questions and we'll start the Q&A once we have all the presenters on the stage. So I just have a few questions for both of you. And the first question is for Sant from Aditya Birla. So my question is, despite significant investments, why do you think most industrial organizations still struggle to scale AI for asset reliability?
Yeah, like I mentioned earlier, building a AI model is not a cost as of now. What happens is people start with a POC and they don't think how I can scale it towards the end or how the end investment will be look like. What happens is they go with a very sophisticated model, prove it, look for a kind of a solution at one machine. Then when they go for a scaling it to the thousands of machines in their plant, they end up with a kind of sunk cost. So the investment doesn't viable at that point of time. So they have to look for a solution which is scalable, which is reliable. People are involved in it, and also they're appreciating it. So start with a small one. That's true. You have to start with a POC, but at the same time, you have to think in mind that if I have to scale it to entire enterprise, then am I be able to do that? If I'm not, then don't go with that solution at the POC level itself.
Yeah, thank you, Sant. My next question is for Harish and Abhishek. So, what is the biggest mistake companies make in Industry 4.0 adoption?
I'll take a first stab at that. Um, See, having interacted with, again, this context is going to be with the MSMEs. What happens is we saw that in the slide where there was discrete manufacturing and all these departments coming in. One of the biggest mistakes that these companies make is they give quality inspection to one set of vendors. They give MES to one set of vendors. So what happens is each of these vendors have their own definition of data. So when it comes to an integration layer, we face a challenge because these are different data sources with different definitions. So I believe that's one of the mistakes that the MSMEs make. And also, if I may make another point, um, they feel digital transformation is 0 to 1, but it has to be done in stages. And that is what the maturity curve talks about. So it's all about understanding where you are, and this is not a vendor pitch. I mean, leaders should sort of self-inspect where they are without any bias, understand where they are on the curve, and have a clear strategy how to move to the next section of that digital maturity curve. So I would conclude here with these 2 points.
Thank you.
Thank you. Hi, everyone. So I'd like to ask the second question to Mr. Sansrol. You have often said that assets should not be monitored in isolation. So what do you mean by that, and why is it so important?
See, let's take another example of like how human behave. You behave differently with your family members. You behave differently with same family member in different context or different scenario. So if your mood is good, you are very good in the morning, you don't scold your child. If your child comes back and says that I failed in the exam, you behave differently. So that's the kind of things are happening. If you are scolding him when nothing has happened, that's an abnormality, right? So for example, child has done something wrong and you are scolding him, that's fine. He has done nothing wrong, but you are scolding him, still scolding him. That's abnormality. So you are the same person, child is the same person. Why this interaction or behavior changed? Because of the environment or the context. You have to bring in that context into it. So like what my offshore or downstream process or upstream process was happening. For example, some upstream process is giving me high temperature. Definitely my downstream machine will give a high temperature. That's not an anomaly. I should not generate alert in that particular machine. I have to look back and see that who is giving me that problem I have to address there. Yeah, so this is the kind of, you have to put it in the context and then say that, yeah, this is the problem. So machine and process are not nowadays separate. You have to look at both in a closed room.
Thank you so much. My next question to Ace Mathematics. You've often said that assets should not be monitored in isolation. So, what do you mean by that? I'm sorry, that's my question. Okay, yeah. How do we move from data to decisions, not just the dashboards?
I'll take that. So your data itself, it is, even though if your data is very concise, data alone does not make any sense. There has to be some amount of decision, some amount of outcomes tied to that data. So for example, if we take an example of CNC machine itself, again, if I take example of my temperature is going high, it can mean many different things. It can mean that I'm running a part which has long cycle times, I'm running up, my coolant is low, I'm ignoring the alarms, many different things. So coming back to that thing, it should not be your decisions should impact, you should flow in some alarm data as well for that thing. So that is why I feel that we need to have decisions and data tied together, and that has to be fed to a machine learning model to know the outcomes, because pattern alone, historical data alone in terms of IoT data does not make much sense, to be honest.
Thank you
Like
so
to
much.
explain?
In the context of dashboard, I'll just give the shortest answer in this ARC forum. Data storytelling. That's all my answer is.
Thank you. Do we have any questions from the delegates? Yeah.
Hi, I am Nilabja. I am from ABB. My question is from AMIT team. In one of the slides, I saw the productivity improvement percentage is 85%. So can you please elaborate what kind of production process, or how did you guys achieve it?
So the slide which you're looking for is auto ballooning slide. Like I mentioned, when you convert PDF drawings or any type of drawings onto your system favorable data, it takes a lot of time to do it manually. So for example, we are talking about if we have a gantry drawing, it has approximately 1000 plus balloons. So a person or a team sitting there manually converting those drawings into Excel sheet and then feeding back those Excel sheet to their own software. Again, someone has to validate it because human error is involved in that case. That process approximately takes 5 to 6 hours. That is what we have observed in reality or in QC departments. So that is the problem that we sought out to resolve, that we'll do something for this thing and we'll try to ease that solution and somehow find a way to tie it to our digital thread as well. So with auto ballooning, since it's based on OCR software, OCR is, as everyone knows, it converts images into text. It extracts text from the images, but that is not all the software do. For example, if I have a reading called dia 256 plus minus something, that same thing can be written in different manner, like dia 256 point something slash LSL slash USL. So more or less those two things mean one and the same thing. So this is where your ontological layer comes into picture. You have to semantically adjust and build a fuzzy logic system so that the system knows that when I read this reading, it means that it is a diameter. There's an LSL USL involved in that case. When I read some GD&T symbol, it knows that this is a GD&T symbol. That means parallelism. LSL USL is not to be added to that. Different types of tolerances are involved based on aerospace industry drawings, based on machine tool industry drawings. So those factors are already considered within the software and gives you a report which is easy to consume by your PFD or control planning software itself. So I hope that answers your question.
Yeah, thanks.
Hello. Hello. Yeah. Thanks for the two sessions. I had actually a follow-up question to what Karthik asked Sant, and maybe I would like to also hear from the AMIT team about it. We talked a lot about sustainability and scalability of any AI solution that we are implementing. But like we had discussed in the previous sessions as well, we cannot start with a bulk, right? We need to start with a small prototype, or we need to target one particular, say, a machine. How do we make sure whatever we take as a prototype, or whatever set of machines we take as a prototype, we don't overestimate it or underestimate it? Because like Sant mentioned, that if it's going to be too easy of a solution or too easy of a problem that we're taking as a prototype, when we're actually going to scale it, it's not going to move in the right direction, and then we'll end up losing the money that we have put as an investment. Vis-a-vis, it's going to be, if it's going to be too complex of a solution, we'll end up spending a lot of time on the prototype itself to find the solution. So how do we hit that right sweet spot on what to choose as our first line of attack?
First thing is, first question you should ask your leader that what's the business problem I'm trying to solve? For example, I'm trying to solve reliability perspective. My machines are failing. So look at that where they're not able to solve the problem. For example, you are going to a machine which is really failing hard. So they have a pain. So you apply the BAM where the pain is there. So don't apply the BAM ki chota sa machine hai, I'll use there. So apply there only. But at the same time, when you are designing a solution or involving any of the vendor, ask them that if I have similar kind of machine or I can scale it to the thousands of machine, how you will going to scale that and what the possible cost will come up with that. Definitely you can negotiate better with the scale, but at the same time you ask what the technology is. How will you maintain these models? Models are not going to learn once and remember that forever. Your context are going to change. Every day your inputs are going to change. How those models are going to learn continuously about the change in the environment. So that's a huge cost involved in it. Otherwise, what will happen? You will have thousands of models. You will again build a team of 50, 60 people who will be looking at those models. Rather looking at earlier they were looking at the data, now they are looking at the models. So this is the kind of thing you have to ask and go for an optimization and automation process. So boss, if it is not going to scale, I'm not going to use it. Yeah, if that answers.
Thank you.
I have another perspective on that. If I were to put that on a graph, so what you're essentially describing is sort of an experimentation, but then with a clear direction. So imagine that there is a graph where the y-axis says, you know, how to do it, and the x-axis clearly defines what you're going to do. So this is where your experimentation falls in. And we all know that POC is something like your MVP, minimal viable product. But there's another way to look at it. It's called Maya, which is most advanced yet acceptable. So where this decision needs to come is, first we need to sort of accept the fact that we're in the experiment phase. So there is absolutely no guarantee that this will result in a sellable product. So whether it's the management or the R&D team or the finance team who's funding this should understand that, see, there has to be at least a 50-50 chance, or else you can't convince the management to fund that. So the pitch that you need to make is that you're at least 50% sure what you're doing and how to do it, and you need the funding to take it to most advanced yet acceptable. So then this would fly, or else it would continue in the experiment phase, or worse, it might get shot down. So
Thank you.
Any other questions?
Thank you. Hi, I'm from L&T Technology Services. So thank you, and good insight what you have shown now. And we talks about like whatever models we are creating, all depends on what data and quality of data we're getting to the models. So have you faced any challenge to see the source of the data, the sensors? If the sensor is reliable enough or working along with the assets, because some assets is a very long life. Say for any motors, it will work for 20 years without any challenges. In that scenario, the sensor health, are you taking care while creating the models? Whether whatever data getting is really correct data.
It's a very important question you asked. The method wise, when I went for POC to scaling the application, I failed around 4 to 5 times. So yeah, I failed around 4 to 5 times. It could not scale because I was using some of the method which was not scalable. Then I cracked and found a method that it is scalable. Now I went ahead and scaled it. When I scaled it, I found that, um, um, and we built the model, started pushing the data, looking at it. 30% of my sensors are not giving right data. 30% of, I'm not talking about data quantity, I'm talking about sensors. People are not knowing that these sensors are not working, Bogus. Like they have to, somebody has to look at those sensors, no? So kind of some point of time, for example, your server is at some location, sensor is some location. Sensor is displaying right data at the same location. They are happy. Your server is getting some kind of garbage. Who will monitor that? So I came up with a next solution what I'm implementing on a scale basis. Like we call it as a data quality engine. What it does is, before going to implement a solution, we ask this partner or the who is the developing the solution. We ask that what are the data you need, what are the kind of data you need. So they give us a list of data. Now what we do is we go for we ourselves go for the plant and look at that data. We have an engine automated and look for the last 1 year data and see that if my data is mature enough to implement that or not. If not, I will start implementing that, how the data will get captured. So that I'll say, hold on, we'll not go for any POC. After 6 months, we'll talk again. It's okay. Because without the wrong data, we'll not go ahead with the POC. Second thing is we started using a live data ingestion model, which will trigger every point of time data is good or not. It started inspecting every data point which is getting ingested to my database. Otherwise, I'm not going to store it. If at all I'm storing it, I'm flagging that this has a problem. This data is not reliable. If you don't do that, that's a poison you are ingesting into your food and you are keeping it in the freeze, and sometime you'll go and eat and see that it's spoiled. I'm not able to consume it. That's where all the AI model and implementation fails, because I have 30% of garbage data sitting in my database. Everybody is saying I have a petabyte of data, terabyte of data. The CEO says that I have a lot of data everywhere. Why AI will not work? We say that if you look at your data, 40 to 50%, you also go back and assess your data in your plant. I'm sure that 30 to 40% sensor will not be giving you the right data. Or over a period of time, for example, this sensor is giving right data, that sensor is not giving that data. So you have to bring back together. You are building a relation, right? When you are building a relation, you have to write data at the same point of time. I will not say that this sensor was giving 6 months right data, now this sensor is giving right data, I will combine them together. What happened to the first 6 months? What happened to the next 6 months? It doesn't make any sense. So that's the kind of data quality engine you have to bring in and make the accountability, so that automated response triggers will go to the right person. He will look at escalation metrics, governance metrics. You have to build in all those things. So data quality.
Yeah, again, coming back to the sensors performance. There are particularly for the process sensors like temperature, pressure, flow, etc. If you are going to analyze based on that data or going to build a model, these sensors are now available with the performance, guaranteed performance by third party evaluation. I hope you may be aware about that, which is classified in the form of SEAL, that is safety integrity level, but that level is nothing but probability of failure on demand. That means lesser the probability of failure of this sensor makes it much more reliable, and such sensors should be given top priority before you talk about quality of the data. Okay, so if you are going to use a SEAL certified sensors, probably your data, at least in the process sector, will be much better. But the cost is at least 5 to 6 times the conventional sensors. So,
yeah, sometimes that becomes a challenging when you are going for transformation. It's a 5-time cost. Should I?
No, but what is the point in going for a data which is not reliable to the level you want it? You define what is the performance required of your model. If you need that my performance, my model performance should be at level 1, then you select accordingly. If you need your performance at level 2, then you select accordingly and you pay accordingly. See, it is
Sir, I
as
would-
good as no that.
Yeah,
Sir,
that's true, sir.
uh,
I'll just take 1 30 second on that. Like, you can use sophisticated sensors also for different machines. For example, there is a few crore of gearbox. We use those kind of sensors. But if it is a blower, it's a small fan. But I need that data. What happens is already OEM has implemented that, and the problem with the data quality is not because of the sensor is giving me wrong reading. It is most of the time the problem is sensor has got failed. Nobody is knowing about it. Some sensor which is not very critical in the plant, sensor's data is not communicating to the server. That's not aware of it. So first we need to bring in the awareness.
No, what I would say, there are many ways to analyze whether sensor is working or not. You can go for the redundancy and then find out.
Yeah.
You can go for 1 out of 1 or 1 out of 2 or 2 out of 3. You can go for the voting and then decide whether the data quality which goes is the right data in your modeling.
Correct.
If your whole modeling base is based on the data, then I think you should address it at the sensor level first. Okay. Thank you.
Sir, I would like to add to this point. So while you mentioned going with different levels of sensors at POC stage is valid, but then the ecosystem also matters. If you are installing a 5 lakh sensor on a 5 crore machine, that is valid. But if I'm trying to install the same 5 lakh sensor on a 20 lakh machine, that is a different thing.
I do not say you do that. What I'm saying, what is the performance you require?
Correct.
You are the decider. What level of performance you want? You want performance have a safe journey in second AC, 2 tire or 3 tire, or you want to travel in a first AC.
Yes.
That is up to you to decide.
Correct.
So particularly you should decide that what model I am going to offer. Or you can ask the client that what level of performance you need from the
So
model.
exactly. So for this type of applications, we generally bring in the stakeholders' perspective as well. So we try to involve them into every decision layers that the model is giving, and then at POC stage we try to work backwards. So if something has failed, the proper person with proper knowledge can easily flag it for
In
us.
short, your modeling should be performance based rather than prescription based.
Correct, sir. Correct.
Okay. There is a clear distinction between the two. Thank you.
Thank you, sir.
Myself Rajkumar from L&T Technology Services. So I have a question for Aditya Group. So see, actually when we go for this AI assisted digital system implementation for manufacturing assets, it might be possible. So when we go for a product level, right? For example, if we take assets like compressors, valves, pumps, right? Which I need to deploy in the plant level, power plant, etc. So assuming that we are doing a POC, we're trying to put all these sensing elements into the product and trying to predict the performance. POC level, it is working. When we go for the scalability at plant level, we see a lot of restrictions, right? Constraints coming from the end users. He will say, no, I don't want to. Though it is going to give a service business because it is going to predict performance, you are able to fix the issues, right? But end customers are not allowing to install this kind of system because of the security perspective. So how do we handle this?
Security perspective means, can you elaborate that? So I would like to hear the context.
Because no, you are taking the end customer data, right? Because you are putting sensor, you are taking my end customer data and you are trying to analyze it and trying to provide. But he doesn't like that actually.
So point is, when I implement the solution, I don't allow my data to go out of the boundary. So how we work is, we ask them to deploy the solution inside the boundary of the or perimeter of the organization. Whatever experiment you want to do, you do a POC, but inside the perimeter. Second thing is, no, data, you said that they're not allowing the data to share. You have to explain that I can do NDA. You give me the sample data. I will not extract the data fully. You give me the sample data, maybe 6 months, 1 year, small data. I'll do the experiment because your solution is not ready. So I'll do the experiment on my end and I'll come up with the solution to you. At the time when I'll deploy it in new premises. I'll not take the data live from the from your system. People are afraid of taking live data because of you are opening a port and giving the access, and some intrusion can happen. That is also going to vanish in a couple of months. We are working on that, so that like remote operation can also started happening nowadays. So kind of thing we are trying to breach that gap, but thing is you can overcome with take the data in offline mode, do the experiment, give them the result, and whenever you are deploying it, deploy it in their environment.
My second question is on the accuracy of the model, right? The digital system, you are going to have the AI assistants. So probably, initially when you are going to do some experiments and all, you may get 60%, 70% output accuracy. When you want to scale it to 90% or above, and is it going to be consistent when you're going to implement it? Definitely there are going to be a lot of challenges you are going to come up, right? So how are you going to fix it? You are going to sell the product, right? This digital system you are going to sell to your customer, right? And after that, if you're getting problems, because it may hallucinate, right? How do we improve the maturity of the model? How do you convince your customer that AI is a journey and it is going to improve its accuracy beyond 95%? So this kind of challenges we are facing, when you are trying to sell it to our customers.
In POC stage, you have oversold your product. Your expectation bar you have matched like this. You have thought about when I'm scaling it, my accuracy is not going to like that. So I have to design my solution that if I implement and scale my solution to a level of what company is asking for, if my accuracy is going to like that or not. So I have to match that level of expectation. This is the mismatch of the expectation from the customer and you. Yeah. So basically what we are trying to say is you are putting all your energy and trying to build a very sophisticated model which is giving very good result to the customer. Now when you are scaling it, you are not considering that I'm not able to scale with that sophisticated model. So your designing has to be such a way that it should be scalable architecture. So for example, I'm saying that if you have a supervised learning method, you are applying a supervised learning method, you are solving one problem, right? You have a lot of data solving one problem. Now you are trying to solve all the problem of that particular machine. Okay. So you will have a 10, 20 models. Each time you will build that. So you have to think like, if I go for a unsupervised model, maybe my accuracy from 99% or 98% would bring it back to 80, 85%, but it's okay. I can scale it. And you have to convince that to the user that, okay, you are getting 20% of false alarms. It's okay. If you give the feedback, I'll overcome it. But with this process, I can scale it. If I go with the accuracy of 95%, you will not be able to manage it. Once I go back, I'll deploy it. You will not be able to manage it. Do you want this kind of solution, or you want a solution which is automatically learning and going better? Yeah, that's the kind of.
Thank you all here for all the very active Q&A session. Now I request to hand over the memento.